So we have mathematics, and we are continuing with the topic algebra. That is the topic that we handled last week, and there was some bit that was left on algebra, so that's what we want to complete in this lesson. So straight to what we need to learn. So we want to look at evaluation and substitution. We want to look at evaluation and substitution. Evaluation and substitution. Evaluation and substitution. Our topic is algebra. So evaluation and substitution. So substituting is replacing a certain letter by a number. So we looked at algebra as a form of mathematics whereby we'll have calculation of numbers together with letters. Now, there are instances whereby you can be given the correct value of the letters. So let's look at examples. An example of what I'm talking about. So example number 1, you can be told, find the value of 4x plus 7. Find the value of 4x plus 7, given that x is equals to 2. Given that x is equals to 2. Now, this is an example of a question on substitution. So if you look at my question, I have 4x plus 7. This is the unknown value. We have the unknown value of x there, which is given. So in this case, we are going to replace the value of x so that we can be able to get the correct calculation. So 4x, x is 2. So that is 2, you put in small brackets, plus 7. So 4 times 2, that is 8. So we have 8 plus 7. So our answer is 15. The answer is 15. That is how we replace the unknown values. So you take the value that is unknown and you multiply by the figure. So our unknown value is x, and x is 2. So 4 times 2, that is 8. 8 plus 7 is equals to 15. So we can have another second example that will include brackets. So we can have a half into brackets 3e plus 2f, 3e plus 2f, close the brackets, plus g. So we have a half into brackets 3e plus 2f, close the brackets, plus g. So given that f is equals to 2, f is equals to 2, e is equals to 2, and g is equals to 3. So we need to solve this. So we replace the values that you have. So a half into brackets 3, e, the value of e is 2. So 3 times 2, so we put it in small brackets like that, plus 2, the value of f is 2, so we multiply by 2. So we put it in small brackets, times 2. Then we move on, close the brackets, the bigger brackets, plus g, which is equals to 3. So we write plus 3. So the next procedure is to solve. So it is a half into brackets, 3 times 2, that is 6, plus 2 times 2, that is 4, close the brackets, plus 3. So Bodmer says you work out what is in the brackets first. So this is a half, 6 plus 4, that is 10. So times 10 plus 3. 2 here 1, 2 here 5. Therefore, we have 5 plus 3. So we have 5 plus 3 as our answer. So you look at the figures representing the unknown values, then you multiply the number that comes before the known value to get your answer. So let's look at a third example on that. Now, the first example did not involve any much of brackets. it was just a direct answer, 4x plus 7. The second one involved brackets. Now the third example is going to be in form of fraction. So it will have numerators and denominators. So let's see how we can answer such like a question. So example number 3 will be 3 into brackets. Example number 3. Let's push it closer. So 3 into brackets, x minus y, close the brackets, plus z over, we have 2x minus y. Given the following values, given that x is equals to 6, x is equals to 6, then y is equals to x minus 4, y is equals to x minus 4, then the last one, z is equals to y plus 3. Z is equals to y plus 3. So when we come to this second example, we realize that the second example has got a sign to show the fraction part. So this is the numerator and this is the denominator. Then we have the unknown values. X is equals to 6, y is equals to x minus 4, and z is equals to y plus 3. So what we do, we solve this part. X is already there. X is equals to 6. So we find the value of y. If y is equals to x minus 4, x is 6. So that is 6 minus 4. 6 minus 4 is 2. Therefore, y is equals to 2. Z is equals to y plus 3. Y is 2. So that is 2 plus 3 to get 5. So the value of z is 5. So after we get that, then we can work out by replacing the values. So we have 3 into brackets. The value of x is 6. So that is 6 minus the value of y is 2. Close the brackets plus z. The value of z is 5. Underline. We come to 2x. The value of x is 6. So that is 2 times 6 to get 12. Take away the value of y, which is 2. So take away 2. So we solve this numerator first, then we solve the denominator, then we see if we can be able to cancel to get the right answer. So we have 3 into brackets, 6 minus 2. We solve this 6 minus 2 to get 4. So we have 3 into brackets, 4 plus 5 over 12 minus 2, that is 10. So we still simplify this upper part. 3 into brackets 4, this means 3 times 4. So 3 times 4 is 12 plus 5 over 10. So 12 plus 5, that is 17 over 10. Now remember, when we started learning this topic, I said we cannot have an improper fraction as your answer. So in this case, what do? We change the improper fraction into a mixed fraction. So 17 divided by 10, you get your answer as 1/7 over 10. You get your answer as 1/7 over 10. So those are the first 3 examples when we are looking at evaluation and substitution. So you simply find the values that are there, the unknown values, the correct figures that have been given for the unknown values. After getting the figures, you replace on the question. Remember, the brackets mean you multiply the unknown value with the value that you've been given, whereby 3x, that means 3 times x. So if x is 2, therefore 3 times 2 is going to be 6. So let's look at other examples also, still under substitution. Now these examples will involve things like square signs. So let's see, if you've been given a square sign, how do we go about it? So we have another example here, our example number 4. Still on evaluation and substitution. So we have example number 4. We can have P into brackets QR minus S squared, close the brackets, over P squared plus Q squared. So we have P into brackets QR minus S squared over P squared plus Q squared. Given the following figures, P is equals to 2, Q is equals to 4, R is equals to 8, and S is equals to 5. So we replace the figures that we have. We replace P with 2, we replace Q with 4, we replace R with 8, and we replace S with 5. Remember, you have to replace for you to be able to calculate. So P, the value of P is 2, so that is 2 into brackets. Q is 4, R is 8. So QR, that is 4 times 8 to get 32. Take away S is 5. So S squared, that is 5 times 5 to get 25, over P squared, that is 2. So 2 squared, that is 4. 2 times 2, that is 4. Plus Q squared, that is, Q is 4. So Q squared, that is 4 times 4 to get 16. So we have 2 into brackets. We take away 32 minus 25. 32 minus 25, that is 7. Into brackets, 4 plus 16, that is 20. So we solve this part. 32 minus 25 is 7. So we have 2 into brackets, 7. So 2 into brackets, 7, simply means we take 2 and multiply by 7. So when we take 2 and multiply by 7, we get 14 over 20. Now this answer, we can simplify it further because they can both be divided by 2. So 2 can divide 14 7 times, and 2 can divide 20 10 times. Therefore, the right answer here is 7 over 10. Before you get your answer, or before you write your answer, you look at the answer if you can simplify. So you simplify it up to whereby it cannot be simplified any further. When you do that, you get your correct answer. So our correct answer is 7 over 10. So in this example, we are looking at questions in algebra whereby you've been given a squared sign. Now pupils tend to confuse a squared sign. So when you are given Q squared, that is Q times Q. So sometimes pupils confuse squared to mean multiplied by 2, whereby if you're given 4 squared, you take 4 times 2. That is wrong. Squared means you take that number and multiply by itself. So if it is 4 squared, that means that is 4 times 4 to get 16. Not 4 times 2 to get 8. So that is wrong. So remember that. So whenever you see a squared sign, you take that number and multiply by itself. We also have cubed signs. That means you take that number and multiply by itself 3 times. For example, if I have let me say 3 cubed, that is 3 times 3 to get 9, then 9 times 3 to get 27. So that is how we work out such like questions. That is how we work out such like questions. So we have another part. These were evaluations and substitutions. So we have equations that involve equal signs. So that is our next part. We are done with evaluation and substitution. We're done with evaluation and substitution. So we come to the next. So we can also look at equations that involve equal signs. Equations that have equal signs. So let's see, we can also have questions in algebra that will have some equal signs. So how do we go about such? So we can have our first example as 3x plus 6, 3x plus 6, 3x plus 6 over 7, 3x plus 6 over 7, plus 2x minus 1 over 3, then is equals to 6. So this is a bit different from the ones we have done, the first. So this example here has an equal sign. The equal sign that I'm talking about is this one here. So there are instances whereby you can have questions that are in form of fractions. We have two fractions, then we have an equal sign on the other side. So like this question, we have 3x plus 6 over 7. That looks like a fraction, plus 2x minus 1 over 3, then is equals to 6. So in order to solve such like questions, the first thing that you're supposed to do, you get the LCM of these denominators. So we get the LCM of the denominators that we have. So we are going to get the LCM of 7 and 3. The LCM of 7 and 3 is 21. After you get the LCM, you multiply both sides by the LCM. So you multiply the first part by the LCM, the second part by the LCM, and the equal sign by the LCM. So let's do it practically. The LCM of 7 and 3 is 21. So to solve this, multiply by 21 here, multiply by 21 there, and multiply by 21 there. So these brackets show that we are multiplying, and we are multiplying everything inside the brackets. 7 into 7, 1, 7 into 21, 3. 3 times 3x, that is 9x, plus 3 times 6, that is 18, plus 3 into 3, that is 1, 3 into 21, that is 7. 7 times 2x, that is 14x. 7 times 1, that is minus 1, is equals to 6 times 21. You get your answer as 126. Remember the other time we're looking at how to multiply when there is addition here and when there is subtraction here. Then we collect our like terms. So we have 9x and 14x. Before collecting the like terms, we said you pick the number and the sign before the number. So in this case, you pick this and that. So we have 9x plus 14x 9x plus 14x. So this one here, 7 times 1 is supposed to be 7, not 1. Sorry for that. So we collect our like terms. We have 9x plus 14x plus 18 minus 7 is equals to 126. So we collect our like terms, 9x plus 14x. So we have 23x plus 18 minus 7, that is 11, is equals to 126. So if you want to remain with the value of x on one side, the number will cross the equal sign. When it crosses the equal sign, the sign changes from addition to subtraction. So we have 23x is equals to 126 minus 11, we get 115. So we have 23x is equals to 115. So we are continuing from there. 23x is equals to 115. So 23x is equals to 115. To remain with the value of x alone, we divide both sides by 23. So when we do that, we cancel 23 here 1, 23 here 1, 23 here 1, 23 here 5. So x therefore is equals to 5. So that is how we solve such like a question that has fraction parts and an equal sign. We multiply both sides by the LCM, and then we open the brackets, collect the like terms, and then you get your answer. So we have another example that looks the same as that. So we can have it here. Example number 2, we have 3 into x plus 2 over 4 minus 4 into x minus 8 over 4. So this calculation is also the same. We multiply both sides by the LCM. So we have the LCM here as 4. So 4 and 4 LCM is still 4. So we solve this first. 3x. So this will be 3x plus 6 over 4 minus 4 is equals to x minus 8 over 4. So we multiply both sides by 4 to remove the decimal part. A whole number, to make it a fraction, you can put it over 1. So multiply by 4, by 4, by 4. Then you simplify. 4 cancels 4. So this is 3x plus 6 minus 4 times 4, that is 16, is equals to 4 cancels 4, x minus 8. So we have removed the brackets and the fractions. So we now collect our like terms. So we have 3x. We have an equal sign here. So x will cross the equal sign and become minus. X is equals to, we start with negative 16. It crosses. So we'll have 16 minus 8. This 6 will cross and it will be minus 6. Now, just to emphasize, when a number crosses the equal sign, the sign changes. So in this case, x crossed the equal sign. So it was a positive, we have a negative. 16 was a negative. When it crosses the equal sign, it becomes a positive. Negative 8 is not changing because it's on the other side of the equal sign. Then 6, this is addition. It changes, it becomes subtraction. So 3x minus x, that is 2x. Then 16 minus 8, that is 8. 8 minus 6, that is 2. So divide by 2, divide by 2. X, therefore, is equals to 1. X, therefore, is equals to 1. So this is how we calculate such questions. We have another part also. We have another part. So we are done with those that involve the equal sign. We can look at algebra that involves inequalities. And I will only do one example. So inequalities, this is an equal sign. We all know that. This means greater than. This one here means less than. So when we have this and that, it means greater than or equals to. When we have this one here, it means less than or equals to. So you can have calculation of questions that have inequalities. So most pupils always change the inequalities and have an equal sign. That is wrong. So you're supposed to work it out with the inequalities as they are. So let me have an example of that. Just one example. One example. So we can have this question here. 3x plus 15. 3x plus 15 is greater than 20. 3x plus 15 is greater than 20. So we have the value of x. We have a known value and a sign that is for inequalities. Then we have a sign. So this one will cross the equal sign. We'll have 3x is greater than 20. This inequality will behave like an equal sign, whereby if a number crosses the equal sign, the sign changes. So it will be 20 minus 15. So 3x here is greater than 5. So we have to have x only. So over 3 over 3. Then we simplify or we cancel 3 and 3. Therefore, x is greater than 5 over 3. We change this 5 over 3 into a mixed fraction. That is 1, 2 over 5. So x is greater than 1, 2 over 5. So this is how we calculate inequalities. And the last part of this question sorry, not question, but topic is always formation of algebraic expressions. So maybe to look at one, then we call it a day. To look at one, Mark, Mike, and Ben shared sweets. Mark, Mike, and Ben shared sweets. So we are looking at formation of equations. Mark, Mike, and Ben shared sweets. Mark got X sweets. Mark got X sweets. Then we have Ben got twice as many sweets as Mark. Ben got twice as many sweets as Mark. So if Mark got X, Ben will be 2X sweets. So that is twice as much. When they say thrice as much, that is X times 3 to get 3X. And then Mike got 2 sweets less than Ben. So Mike got 2 sweets less than Ben. 2 sweets less than Ben. Ben had 2X, then minus 2. If it's 2 sweets more than, that will be 2X plus 2. Then you're asked, how many sweets did they have all together? So that is X for Mark plus 2X for Ben plus 2X minus 2 for Mike. Then we solve by collecting like terms. X plus 2X plus 2X, that is 5X minus 2. So the total number of sweets they had is 5X minus 2. So that is how we solve questions in algebra. There are many forms of questions. Once you know how to work them out, even if they are twisted, you can be able to have it right. So I want to conclude my lesson from there. I've been your teacher, Teacher Steplaton. Have a wonderful day ahead.